algebra students, this is our introduction video on equivalent equations. The first part of this is just what an equivalent equation is. You've actually seen them before. It's two equations that have the same solution. Already in this unit, we've seen different stories or situations where there's multiple equations you can use to represent that story. Those equations we call equivalent equations. Another example of this, we've got the story Samantha is 2 years older than her sister Allie. Let S represent Samantha's age and A represent Allie's age. There's a couple different ways you can think of this. You could think of this age difference as a difference and use subtraction. Samantha's age minus Allie's age equals 2 years. Or you could think of it with addition. If you take the younger sister, Allie, and add 2 years, it gives you the older sister, Samantha's age. Two different equations that are fundamentally different, right? We've got one with addition, one with subtraction, but they both represent the same solution. We call these two equations equivalent equations. The main focus of our lesson is going to be on how you can create equivalent equations and how you know if two equations are equivalent. And so the big idea of creating equivalent equations is you can create them by using the same operation on both sides. That's going to sound really similar to how we describe solving equations. Remember, if you do something on one side, you've got to do it on the other. So for example, if I wanted to create an equivalent equation for this equation here with two variables, as long as I'm doing the same math on both sides, I'll create an equivalent equation. So I could do anything. I could multiply both sides of my equation. So multiply this side of my equation and this side. As long as I multiply by the same number, I'm going to choose a random number, 4. It will give me an equivalent equation. So for example, the equation 8x plus 12y equals 32 would be equivalent to 2x plus 3y equals 8. They would have the same solutions, the same graphs, the same tables, the same everything, as long as you're doing the same math. Now, if I only multiplied 4 on one side, if I said 8x plus 12y equals 8, that's not equivalent because I'm not doing the same operation on both sides. You can also do this with equations with one variable. We're used to, when you see an equation like this, subtracting 1 on both sides. We're really focused on solving equations. And sure, 3x plus 1 equals 10 and 3x equals 9. Those would be equivalent equations. But there are so many other things you could do. You could, instead of subtracting 1 on both sides, you could add 1 on both sides. I know that doesn't help us solve the equation, but the theme of today's lesson isn't solving equations, it's just making equivalent equations. So for example, 3x plus 2 equals 11 would be equivalent to 3x plus 1 equals 10. Especially if you have equations with only one variable, you can check to see if they're equivalent by making sure they have the same solution. So for example, if we finish solving this equation over here, I could divide both sides by 3, and I see the solution is x equals 3. This other equation I just made here, the 3x plus 2 equals 11, it has the same solution. If I put the number 3 for x, notice 9 plus 2 does give me 11. It works out the same way if we put 3 here, plus 1 equals 10, 9 plus 1 equals 10 is the solution. They've got the same solution of 3, so they are equivalent equations. The last type of question you might see in this lesson is if I give you two equations and I ask if they are equivalent. So for example here, our 2x plus 1 equals 4 and 5x plus 1 equals 3x plus 4. The focus of these is going to be, can you identify what math I did? If I am doing the same operation on both sides, it means it's equivalent. But if I'm doing something silly like adding 5 on one side and subtracting 3 on the other, that's not going to be equivalent. Looking at these two equations here, it helps if you can identify what didn't change and what does change. So for example, I'm noticing both equations have that plus 1 there, that didn't change, and both equations have a 4 there. That part didn't change either. But the part that did change on both sides of our equation, our 2x changes to a 5x, and this side over here had no x's, but afterwards it has 3x right there. And that helps me see the change is that someone added 3x on both sides of the equation. 2x plus 3x equals 5x, and 4 plus 3x is 4 plus 3x. You are allowed to do this. We're allowed to add 3x on both sides of an equation. That's the same operation. So since you're allowed to do this, my answer would be yes, they are equivalent. We'll do more practice like this in today's lesson, but I think you are ready. Thanks so much for watching. Bye, y'all.